So now that we've talked a bit about what a framework is in general, and I've given you a couple high-level examples of frameworks, and I've talked about the characteristics of frameworks, in my experience, most people have a sort of a glimpse of what this stuff is about, but they still don't really have a good deep feeling or understanding or intuition about what we're talking about. So I'm going to start focusing this more specifically and anchoring it in the context of Android's concurrency frameworks, which should matter because that's what your next programming assignment's about. So we're first going to talk about why Android even needs to have its own concurrency frameworks, and then we'll talk specifically about what those frameworks do. So you might think, why do we need frameworks in Android? Doesn't it already have all this cool Java stuff? I mean, we've already talked about the fact that Android and Google copied all those Java APIs, so they've got, the executor service and the executor completion service, and they've got threads and locks and all this good stuff. So why do they need anything else? Well, the main reason is that there's certain design constraints that Android provides or imposes on developers that are complex enough that they're not satisfied by using the Java concurrency and synchronization mechanisms out of the box unchanged. So let's take a look at some of the examples of what motivates this. The first is that for a variety of reasons, if the user interface thread, that's the main application, main activity thread in Android, blocks for more than a short amount of time, like let's say 3 seconds or so, then the Android framework layer notices this and says, aha, something's gone awry with the main activity, and I'm going to send it the application not responding exception. And you may have seen this before. If something's going wrong with your app, let's say you're writing an app or you're using an app that's not very well designed, and it's not responding, then you'll get this little dialogue popping up saying, hey, your app isn't responding. Do you want to close it? And if you say okay, it'll go ahead and kill it. Otherwise, it'll just wait around for longer. But the idea is that they don't want to have long-running operations in the user interface thread. So that's the key theme. Another constraint is, and this is sort of related to this, network calls for sending and receiving data across the network are disallowed on the user interface thread by default. So if you attempt to make a network call on the user interface thread, then you're going to get an exception, and it's going to send you the network on main thread exception, and the indication here is that something has gone awry, and that's because you try to use a network call on the main thread, the UI thread. Similar idea. The idea is that a networking call could block, because networks are typically a lot slower, depending on the network and its congestion at any given point in time. So they disallow that by default. Yet another design constraint that Android provides is that non-user interface threads, in other words, threads you might spawn to run in the background, can't access the user interface toolkit components directly. So if you have a background thread that's doing some computation, and then it wants to update something on the user interface that the user would see, can't do that. If you try to do that, you'll also get an exception, and it'll fail. The reason for this is that the user interface toolkit components aren't thread safe, so they don't have any synchronizers in them. The user interface toolkit components, the classes and objects and so on, always expect to be called only in the main thread of control, or the user interface thread. And if they're not, then they throw an exception. And you can learn more about why that is if you read this link. There's a good reason for this. The primary reason for doing this is to try to make life easier for application developers, because you don't want them to have to understand locking if they don't do complicated things that require locking. And by and large, if you use Android properly, with what we're about to talk about, you don't really have to put any locks in your code for the most part. So the problem is, why we can't just use the Java stuff out of the box is that the concurrency mechanisms that Java provides don't address these Android-centric constraints. These are Android platform-centric things, not uncommon, by the way, with other user interface toolkits that you might encounter, but they're things that you have to work around with Android. And so just using the Java stuff out of the box is not going to solve these problems. So what do? Android defines a couple of concurrency frameworks intentionally designed to handle all these constraints that the Android platform imposes on software developers. And we'll see here, one of the frameworks is the Handlers, Messages, and Runnables framework, which I have coined the term Hammer. So the Hammer framework, just because it's a cool name, you think of Thor or something. And then the other one is the Async Task framework. So we've got tasks and we've got hammers. And you'll see that we'll talk about those things. And they allow you to do some computations in the background, which can block, because they aren't running in the user interface thread. But then when they're finished, they can route the results back to the user interface thread, the one and only user interface thread, in order to display that information to the user in some useful way that won't violate the constraints of the toolkit's non-synchronization or non-thread safety properties. Okay, so if you're bored and want to amuse yourself, I wrote a little app called Buggy Downloader. And the Buggy Downloader app helps to motivate the need for these frameworks. So what it does is, if you run it, it gives you a couple of different buttons, and you can run Buggy 1 or you can run Buggy 2, and it'll try to download an image, and it'll fail spectacularly, as we'll see in a second. That's actually me when I got my PhD. My advisor was putting my hood on. I don't actually have 4 arms, just in case you were curious. But I also had a lot longer hair back in those days. So if you run Buggy 1, it'll throw an exception because it attempts to download the image in the user interface thread. So you'll get an exception saying that there's a exception in Buggy 1 because you tried to use the network, you tried to use network calls in the main thread. There are ways of disabling that exception, that check, but it's not a good idea. Buggy 2 also throws an exception because what it's trying to do here is it's trying to have a background thread access a user interface component. So it basically, I mean, these are not the world's most enlightening exception messages, but basically it's telling you that it says only the original thread that created a view hierarchy can touch its views. What the heck does that mean? Well, what that means is that you tried to have a background thread work on a UI toolkit component, a view object, and it doesn't let you do that. Okay, so those are just some examples of kind of what not to do, and more specifically, or more importantly, how Android has these constraints that motivate the need for concurrency frameworks to simplify dealing with those constraints.